In this video, I will be teaching you how to solve mass-to-mass stoichiometry problems. The first thing we want to do is read the problem carefully. This one says, calculate the mass of nitrogen required to produce 5.00 grams of ammonia. And the formula for ammonia, NH3, is provided for those of you that are unfamiliar with ammonia. There are three things I need to solve this problem. The first is the balanced chemical equation, which is provided for you here. If the equation were not balanced, I would have to balance that in my first step. And I will provide a second video showing you how to balance chemical equations if you're unsure of how to do that. The other two pieces of information are found over here. What this is the molar mass of ammonia, which is the substance I'm starting with, and nitrogen, which is the substance I'm trying to calculate. These values come from the periodic table. And again, if you're not sure of how to calculate those values, I will produce another video that will help you with that. The first thing that I need to do in this calculation is convert my mass of ammonia, which is 5.00 grams, into moles. The reason for that is these coefficient values, which relate, in this case, the nitrogen and the ammonia to each other, can only be used if we have moles as our unit. I'll be setting this calculation up as a dimensional analysis calculation. So I'm going to say 5.00 grams of NH3 times 1 mole of NH3 per 17.04 grams of NH3. The reason this works in terms of dimensional analysis is over here I've got my grams of NH3 in the numerator, and over here I've got my grams of NH3 in the denominator, and so they will cancel each other out. Now, for those of you saying, wait a second, there's no fraction to start out with over here, remember that any value can be written as a fraction if we simply draw a fraction bar and write it over a denominator of 1. So that does count as a fraction. And again, we have the numerator and the denominator units canceling each other out. At this point, if I were to complete this calculation, I would have my ammonia, my NH3, in moles. I would have converted to moles. So now I can use what we call the mole ratio from the balanced chemical equation. And in this case, I have 1 mole of nitrogen is needed to produce every 2 moles of ammonia. Again, I can rely on some dimensional analysis here to set this up. So if I have my 1 mole of N2 in the numerator and 2 moles of ammonia in the denominator, my moles of ammonia will cancel each other out, and if I stop my calculation at this point, would now have moles of nitrogen. My last step, because I am asked to calculate the mass of nitrogen rather than the moles, is to convert this from moles of nitrogen to mass of nitrogen. Again, I can use some dimensional analysis, 28.02 grams of nitrogen for every 1 mole of nitrogen. And again, I have on opposite sides of the fraction bar similar units which are going to cancel one another out, and then that shows me that my ending unit is grams of nitrogen, which does measure mass, and that's exactly what I want. In terms of the actual calculation itself, I'm going to start with 5. I will actually divide by 17.04. This is set up as a multiplication problem, but any number multiplied by a fraction with a value in the denominator is actually division. So 5 divided by 17.04, get that answer. Divide that answer by 2, and then get that answer and multiply it by 28.02. If I do all of that correctly, I should end up with 4.11 grams of N2.